Yeah, it's going to be good. It's going to be good. Yeah. All right, so here we go. Thank you. Here we go. Yeah. When the sun goes around the earth, or when your heart beats like this, or if you're watching my daughter on her swing, right, or you can watch the waves crashing in. These are all predictable events because they have this cycle, this pattern, right? If they have a cycle or a pattern, this is called a periodic function. Periodic function. Yes. All right. One complete pattern, sorry, is one cycle. Yeah, come on. Here we go. Okay. And the period of a function is the horizontal length of just one cycle. All right. Now, on your homework or on your sheet, it's going to say graph either one cycle or two cycles. For our purposes, just graph one period, one cycle. Okay? By a cycle, I mean, hello? By a cycle, I mean just one start to finish area. So, for example, in this one, you can start up here at 2, and one cycle will be where it goes back up to 2. So that's one period long. Let me pause this real quick. I apologize. Yeah. Here we go. It's okay, good. Okay. Woo! All right. Here we go. Yeah. Okay. The amplitude of a period is the height from the center. So from the center, it's going to go above it and below it, right? The amplitude is going to be the distance from the middle, and it should be the same on both the upper and the lower half. Yeah. To find the amplitude, it's a formula that could be, I mean, you could use it later on. We're not going to use it so much. It's the average of the maximum and the minimum values. So you just subtract the high from the low and then divide by 2. Yes, love? What's up? Yeah, so like the amplitude from the center is like from here to here, but that should be the same amplitude from here to here from the bottom. Right? Oh, thank you, the blank. Yes, sir. We're so smart. Okay? Okay. All right. Nitty-gritty, nuts and bolts. It looks really hard, but graphing is one of the easiest things you'll do here. I promise. I promise. Here we go. All right, here we go. Let me point out again. Right? When we're graphing the sine function, we want just the ones and zeros, right? So the ones and zeros, here's where you take out your highlighter. The ones and zeros happen at 0, pi over 4, nope, pi over 0, pi over 2, thanks love, pi, 3 pi over 2, and 2 pi. 1, 2, 3, 4, 5. Those are the big 5. Okay? The stuff in between show you that it's just leading up to 1. So at 0, sine is 0, like this. At pi over 2, sine is 1, right? All the stuff that leads up to pi is like 1/2, root 2 over 2, root 3 over 2. All of these numbers are getting closer and closer to 1. So that's why I included it in this chart. But you don't need to graph that because it's a pain. Yeah? The pattern for sine goes 0, 1, and then at pi, it goes back to, sine 0, then down here it's -1, then back up to 0. So, the pattern for sine is 0, 1, 0, -1, 0. Okay? Sine always starts at 0. Okay? So when you graph this puppy, here you go, delete. Yes, all right. We're graphing, when you graph this thing, the x's, these things, so all you have to do is on your x-axis, here's 0, and then pi over 2, and then pi, and then 3 pi over 2, then 2 pi. Kind of sort of evenly space out those 5 intervals. Okay? And then our y's, our high and low, is 1 and negative 1. So here's 1, here's negative 1. Okay. So easy to graph. Here we go. 0, 0 is at the origin. Yeah. And then it goes at pi over 2, we go up to 1. Then at pi, we go back to 0. And then negative 1, and then 0. Now, you may have this urge to draw straight lines and make it jagged. But sine is not like just a bunch of like jagged lines. It's curved. The curve is sinusoidal. Repeat after me, sinusoidal. Yeah, it sounds like you have something in your sinuses, right? No, sinusoidal. So, curve, 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 right? Okay? You can continue this pattern. You can continue this pattern as, you know, as much as you want. It continues on forever and ever. But this right here, from this point to this point, is one period. And I always write it in red. Why do I do that? Every time. Here we go. All right. Here we go. So, if you're taking a look at this graph of sine, right? Domain and range. Yay, algebra 2. Domain is all the x values. So the domain for sine, is it going to come up? I don't know. Yeah, there it is. The domain for sine, it goes on forever and ever. So it goes from negative infinity to positive infinity. Yay, algebra 2. Yeah, right? The range is all the y values. The highest it goes is 1. The lowest it goes is negative 1. So the range goes from negative 1 to 1. Right? 1 period, the length of 1 period is 2 pi. You can see the length of 1 period is 2 pi. And in this case, my amplitude is 1. But Ms. Fleck, that's too high. Yeah, it's from the middle. So from the middle, it goes 1 up and then 1 below. So the amplitude from both the top and bottom is just 1. You got it. You got it. Okay. Okay. Yeah. All right. Oh, we're ready for cosine. Do you remember why Eddie can't buy a car? Because he ain't got no one to cosine. Because I'm broke. All right, whichever. Okay. Here we go. For the cosine, again, all we need are the big 5. So I'm just going to go ahead and put in the 0, the pi over 2, pi, 3 pi over 2, and 2 pi. All right, not too worried about the stuff in the middle. Good? All right, what's the cosine at 0? It is 1. Then 0, negative 1, 0, 1. Bam! There it is. 1, 0, negative 1, 0, 1. It's right there. Yes. Okay, I know. I scared you by running. Here we go. Paige, I'm trying to get you out of here. Delete, delete. Okay. Here we go. Yeah. Because you got, yeah, I got some time. All right, here we go. All right. So for cosine, right, the x values are 0 again, same thing. Pi over 2, pi, 3 pi over 2, and 2 pi. We still have 1 and negative 1. Okay, now, pretend you're like a Greek statue and you're going like this, right? Have you seen that Greek statue go like this? This is cosine. It's going to be like a Greek statue like this, right? Yeah, let me show you, All right, the griffin, the best part, they stop you at the top and then they drop you, right? Cosine starts at the top. Cosine starts at 1, then it goes 0, negative 1, 0, then back up to 1. That looks like a parabola, Miss Fleck, or it's not. Sinusoidal. So curve, 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 right? Again, you can continue this pattern forever and ever and ever. Dot, 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 right? It continues on. They were just looking at one period, and I remember this time. Ha ha ha! That's one period. There you go. Yeah, it's all good. It's all good. Yeah. All right. So that's just one period of cosine. Yeah. Here you go. What's the domain? Does it go on forever and ever in the axis? Yeah, it does. No, it just keeps on going. Remember the sine, the wave just keeps on going. So the domain is still negative infinity to positive infinity, right? For like regular cosine, yes. Yes, and actually you're right. Cosine, it doesn't matter because cosine never ends, so domain will always be that. The range, though, for regular cosine goes from 1 to -1. But if we can shift this thing, holy shift, check out the asymptote on that mother function. We're going to get there. We're going to get there. Yeah. Okay? And then the period is still 2 pi, amplitude 1. Good times. Good times. Serious. All right. You haven't seen my magnet? All right. Here we go. That's over there. You'll see it one day. Just giggle. All right. So here we go. Let's talk about the anatomy of an equation for sine and cosine. Yay? Yes. All right. If there is a number in the front of sine and cosine being multiplied to sine and cosine, we're going to go ahead and give that the letter A. It's the letter A because that stands for the amplitude. Yeah, right? So in both sine and cosine, that A stands for the amplitude. And I remember this time. Good. All right. Inside the cosine, if the number inside the sine or cosine, if the number is being multiplied to the x, this will determine your period. So to find your period, you just go 2 pi divided by whatever b is in there. Okay? So again, for that thing, you go, for the period, it's just 2 pi, because regular cosine is 2 pi, and just divide the b out, like so. And what that does is it can either shrink your sine curve, or it can stretch it out, right? So that's what that does to that b does to it, right? And then your a, like makes it taller or makes it shorter. Yeah? Okay. All right. Here we go. Am I going too fast? Here's example 1. Come back. Okay, next question. 145, love. 145, and then you guys start, you get done with lunch at 2:15. Yeah? Yeah. Okay. All right. So here's the deal. When you set up, when you're ready to graph, right? First of all, you know you're in sine, so I already set this one up for you. Later on, you're going to have to do it yourself. You go from 0 to 2 pi, all right? Then the pattern for sine goes 0, 1, 0, hello, -1, 0, right? Okay? So if you change the amplitude, all you have to do is multiply 1/2 by that number. So 1/2 times 0 is 0. Half of 1 is 1/2, 0, -1/2, 0. So take a look at what this does. Let's cry. Here we go. Take a look at what this does to the graph, right? So originally, you had 0, pi over 2, pi, 3 pi over 2, and then the 2 pi, right? Before we had 1 and -1. This time, you're shrinking it. Now we're at 1/2 and -1/2, right? So your graph, instead of going all the way to 1, is actually going to be a little bit shorter. Wait a minute. Bum, bum. Oh, there it is. Da, 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 da. That's better. There it is. There's one period. Delete. I'm getting out of the way. I promise. Alright. Huh? I need a bigger graph. You can grab. You don't have to use that. You can graph anywhere on your paper. Yeah. I didn't stick to the negative 1/2 for a minute. Donnie judges me. Okay. What else we got? All right, 2 more. That's it. Just 2 more. I got you. I got you. Okay. Here we go. Oh, sorry, love. Sorry. Let me go back. It's good? Okay. All right. Here we go. Oh, no more charts. What do we do? No big deal. No, and you don't even need to make a chart. Let me show you how to do it. Ready? Okay. Here we go. All right. In order to set this up, first of all, the B in here is going to change. Okay? So to set up our chart, first we need to set it back to figure out what our intervals are. Since sine happens between 0 and 2 pi, right? We just put that 1/3 in between 0 and 2 pi. I haven't seen this since algebra. Right? Yeah. Okay. Then solve for x. So what do we do to get the x by itself?
Wait, what'd you do?
To get the x by itself, you would just multiply everything by 3. Okay, so we're seeing what would that number inside, what would that do to the interval, the period? Right? It is. It's going to stretch it out, isn't it? So if you multiply by 3 to every piece, right, then you're going to get 0 is less than x is less than 6 pi. So this time, instead of going from 0 to 2 pi, we're going to go all the way to 6 pi. In other words, we're stretching that string out. Okay, here's how I like to do my big 5. 0 to 2 pi is the normal interval for sine, right? Yeah, but this time we're doing 1/3 of that, so you have to divide, multiply by 3. Okay, so I like to put the 0 and the 6 pi right there. Okay, now what you do is find halfway. So what's halfway between 0 and 6 pi? It's 3 pi. Okay, if you don't know how to do that, all you have to do is add it and divide by 2. So 0 plus 6 is 6 divided by 2 is 3, right? What's 0 plus 3? 3 divided by 2, but 2 doesn't go into 3. So the way you can write this is 3 pi over 2, like that. Okay, so add divide by 2. If the 2 doesn't divide, just put it in the denominator. Yeah? Let's try it again. 3 plus 6, 9. Does 2 divide into it? No. 9 pi over 2. That's it. Add divide by 2, and you found the middle. Okay, here we go. Now, we are doing sine, right? Since we're doing sine of that, sine goes 0, 1, 0, -1, 0. Yeah? Okay, here we go. The first line is your x-axis. So this thing, let me highlight. Okay, so this thing goes in your x-axis, right? And then the second one, I know you guys don't have a different highlighter, I'm sorry. All of these things go on the y-axis, okay? So when you set up your graph, you still start at 0. Then you got 3 pi over 2, 3 pi, 9 pi over 2, and then 6 pi. Let me move all of this. I'll get out of the way in just a second. Yeah. I'm sorry? You have a Rolex on your wrist. You have a wrist on your wrist. Oh, no, it's not moving. Hang on. I gotcha. Because it's hard to see. There it is. Oh, man. Okay. Well, how if I did this? Can I move it up? Yeah, I think I can move it up. There it is. Okay. Sorry. Okay. Yeah. here we go. Still 1 and then -1. It's going to be the same picture. All the thing that really matters is like what's the number on your x-axis. That's it. So it's still 0, 1, 0, -1, 0. And you still have that beautiful sinusoidal curve. But this time it doesn't go, the one period is 6 pi instead of 2 pi. Okay? Okay. Let's try one more. Yeah? Okay. Here we go. Cosine of a half x. All right. Here we go. Cosine goes from 0 to 2 pi. Right? So to figure out the half part, we need to isolate the x. So how do we get the x by itself? Multiply by 2. 2 times 0 is 0, x, and then 4 pi. So the 0 to 4 pi is my period. Yeah? 0 plus 4 divided by 2, 2 pi. So 2 pi is in the middle. Right? Anthony, I feel like that should be your rap name. 2 pi? Nope. All right, here we go. 0 plus 2 divided by 2, 1. That makes sense. 2 plus 4 is 6 divided by 2, 3 pi. Yeah, that's it. That's it. Okay? And then since we're doing cosine, all you have to do is memorize the pattern. Cosine starts at 1. It goes 1, 0, -1, 0, 1. Done, son? X-axis, Y-axis. Okay. So we got 0, pi, 2 pi, 3 pi, 4 pi, 1, -1. And then we make that beautiful Greek statuesque thing. All right, here we go. 1, 0, -1, 0, and then 1 goes something like this. And they all live happily ever after. Yay? All right. Here we go. For graphing, I don't expect you to use graph paper, but if you want graph paper, you're more than welcome to. Tonight for homework, I have some graph paper in the back if you need some. Tonight for homework, you're just doing 9 through 27 by 3s. If it says graph 2 periods, just graph 1 period. Okay, that's it. All right, hang on, sir. Be right there. All right, my dears.